In the series of alkanes and cycloalkanes, we will discuss in today's episode the introduction of cycloalkanes, nomenclature of cycloalkanes, along with methods of formation of cycloalkanes. So, first we must have to know that what are the cycloalkanes. Cycloalkanes or cycloparaffins are saturated hydrocarbons in which the carbon atoms are joined by single covalent bonds to form a ring. They are also called alicyclic compounds. These compounds have cyclic structures, but resemble aliphatic, that is open chain hydrocarbons compounds in many properties, hence are called alicyclic compounds. The prefix ali is added because of their similarity of aliphatic compounds. The unsubstituted cycloalkanes form a homologous series with the general formula, that is CnH2n, when the molecular formula of saturated hydrocarbon corresponds to the general formula CnH2n minus 2. The compound contains two rings is of CnH2n minus 4, 3 rings, etc. The first member of the series is cyclopropane. Propane means 3 carbon atoms. So, the molecular formula of this compound is C3H6. So, now we will discuss nomenclature of cycloalkanes as per IUPAC nomenclature. IUPAC means International Union for Pure and Applied Chemists. First, we will discuss about locating prefix. Cycloalkanes are also known as polymethylene because these have methylene units, that is CH2, linked together in the form of a ring. Thus, cycloalkanes are named by putting a prefix such as tri, tetra, etc. Tri for 3 carbon atoms, tetra for 4 carbon atoms before the word methylene. Now, this locating prefixes we will discuss in the structure. This structure shows molecular formula C3H6 and the name is cyclopropane, or it is also known as trimethylene. Tri is using for carbon 3, carbon 1, carbon 2, carbon 3, and in this structure carbons are 4 in number. So, known as cyclobutane, and also it is called as tetramethylene, tetra for 4 carbon atoms. In this structure we are seeing that for carbon 5 we are using pentamethylene and common name is cyclopentane, and in this structure that is also known as cyclohexane because it is having 6 carbon atoms in it. So, also known as hexamethylene, hexa for 6 carbon atoms, that is carbon 1, carbon 2, carbon 3, carbon 4, carbon 5 and carbon 6. So, we will discuss this in this structure means 1, 2, 4 trimethyl cyclopentane. So, this is carbon number 1, this is carbon number 2, 3 blank, 4 is having another substituent. So, the IUPAC name of this compound is 1,2,4 trimethyl cyclopentane. Note 1,3,4 trimethyl cyclopentane means 1, 2, 3, 4, 5. So, the actual, or you may say the right name of this IUPAC name of this compound is 1,2,4 trimethyl cyclopentane, not 1,3,4 trimethyl cyclopentane, because this is empty location. So, we cannot use in this structure by using IUPAC nomenclature. So, it is of two types, as if 2 or more alkyl groups have potentially the same number them alphabetically. This is the ethyl group, that is CH3 CH2, and this is the methyl group. So, according to alphabetically the name will be 1 ethyl 2 methyl cyclohexane instead of 1 methyl 2 ethyl cyclohexane. So, in this structure we are giving preference to ethyl, not to methyl. Treat other substituents exactly like alkyl groups. In this structure we are seeing that the IUPAC name of this compound is 1 bromo 2 methyl cyclohexane. Determine the cycloalkane to use as parent chain. The parent chain is one with the most amount of carbon atoms, that is longest chain. If there are 2 cycloalkanes, use the cycloalkanes with more carbons as the parent chain. This will show in this structure that cyclomethyl pentane, this is the methyl group and this one is the pentane. So, according to IUPAC nomenclature, the name of this compound is cyclomethyl pentane, and in this structure we are seeing that meth, eth, prop, but, pentane, carbon 1, carbon 2, carbon 3, carbon 4. So, butyl, because it is in cyclic structure. So, IUPAC name is cyclobutyl pentane. Alkyl chain must be used as the primary parent chain. If there is an alkyl state chain that is greater in the number of carbons than the cycloalkane, the alkyl chain must be used as the primary parent chain. Cycloalkanes acting as a substituent to an alkyl chain as an ending by -yl. As we have seen in alkanes, we were using suffix -ane for them, and in cycloalkanes we are using -yl as suffix, and therefore, must be named as cycloalkyl. This will be clear in this table. This is the cycloalkane, that is cyclopropane, cyclobutane, cyclopentane, cyclohexane, and according to cycloalkyl, cyclopropane will be termed as cyclopropyl, cyclobutane as cyclobutyl, cyclopentane as cyclopentyl, cyclohexane as cyclohexyl. Continuously, cycloheptane as cycloheptyl, cyclooctane as cyclooctyl, cyclononane as cyclononyl, cyclodecane as cyclodecanyl. So, YL, yl is using as suffix in the nomenclature of cycloalkanes. Now, we will discuss the number of carbons in cycloalkanes. The carbons with functional groups or alkyl groups have the lowest possible number. A carbon with multiple substituents should have a lower number than a carbon with only one substituent or functional group. Now, we will discuss the number of carbons in cycloalkanes, or you may say the number of carbons in parent chain. When the numbers corresponding to the substituents are added, its sum will be the lowest possible, which is clear in this structure. As we have started the nomenclature from this side instead of this side, because this locant is situated at carbon number 3 and this locant is situated at carbon number 6. If we started from this side, then we obtained that carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6 having the lowest possible sum. But if we have started from this one C 1, 2, 3, 4, 5. So, first locant is on 5th position instead of this 3rd position. So, it is as per the IUPAC nomenclature. We will give the numbering of carbon which is having the lowest possible sum. The IUPAC name of this compound is 1-ethyl 3-methyl cyclohexane, because this carbon number 1 is having ethyl group, that is CH2 CH3 and this is the methyl group on 3rd carbon atom. So, the sum of this carbon 1 and carbon 3 is equal to 4. If we have the comparison of numbering of carbon atoms, then we will found that this structure is having first carbon, second carbon empty, third empty, fourth empty, fifth carbon atom is having methyl group. So, as per the IUPAC nomenclature, the name of this compound is 1-ethyl, that is CH2 CH3 and 5-methyl cyclohexane, but according to numbering of carbon atom, this is the false nomenclature. So, because it is having carbon 1 and carbon 5. So, the sum of this carbon 1 and carbon 5 is 6, which is greater than this structure, because the structure follows the rule, that is number of carbons. So, this is most appropriate structure as per the IUPAC nomenclature. Now, we will discuss the alphabetical order. When naming the cycloalkanes, substituent and functional groups must be placed by alphabetical order. The same we have already discussed the nomenclature of alkanes. This structure shows that carbon number 1 containing chloro group, carbon number 2 containing bromo group, and this carbon number 4 is having methyl group. So, as per the alphabetical order which is using in IUPAC nomenclature, we will pronounce this structure as 2 bromo, 1 chloro, 4 methyl cyclopentane. Bromo comes first as per the alphabetical order and followed by chloro. Now, we will discuss the functional group with the highest priority. Indicate the carbon number having the functional group with the highest priority. According to alphabetical order, a dash must be placed between numbers and name of the substituents. It is clear in this structure, this chloro group is attached with this carbon number 1. So, the IUPAC name of this compound is 1 chloro cyclobutane. Cyclo due to the cyclic structure, butane because it is having 4 carbon atoms. So, after the carbon number and the dash, this one, the name of substituent can follow, where there is only one substituent on the parent chain, indicating the number of the carbon atoms with the substituent is not necessary. The use of prefix di, tri and tetra according to substituent groups, it is clear in this structure. This carbon number 1 containing 2 methyl groups on same situation, and this carbon number 2 is having bromo group. So, according to IUPAC nomenclature, the name of this compound is 2 bromo 1,1 dimethyl cyclohexane, that is 2 bromo, that is according to alphabetical order 1,1, because these both methyl groups are located on this carbon number 1. So, we will use 1, 1 then dash as per the nomenclature, then dimethyl because these methyl groups are 2 in number, then cyclo because it is having cyclic structure, hexane due to the presence of 6 carbon atoms, that is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5 and carbon number 6. If there is more than one of the same functional group on one carbon, write the number of the carbon 2, 3 or 4 types. If there is more than one of the same functional group on one carbon, write the number of the carbon 2, 3 or 4 times. When there are 2 of the functional group, it must have the prefix di, means if these are 2 in number, these bromo group, then we will use di prefix. When there are 3 of the functional group, it must have the prefix tri. When there are 4 of the functional group, it must have the prefix tetra. However, these prefixes cannot be used when determining alphabetical priorities. There must always be commas between numbers and dashes between numbers and names. It is indicating in this nomenclature, or you may say that in this name 2 dash bromo dash 1 comma 1 dash dimethyl cyclohexane, which is following the rule as per we have described. Now, we will discuss the use of cis and trans forms in cycloalkanes. If the substituents of the cycloalkane have a relation of by way of cis or trans. Cis means when both functional groups are according to plane, or you may say that both functional groups are attached at similar direction, or trans. Trans means opposite, means when two functional groups are located at different carbon atoms and different planes. So, you may say that cis form is just like this, or you may say the boat like, and the trans form is just like this, or you may say the chair form. Indicate so by placing cis or trans in front of the name of the structure. It is clear in this structure. The IUPAC name of this compound is cis 1 chloro 2-methyl cyclopentane, because these both are in same plane and shown by this dark colored bonding. This chloride and this methyl are in same plane. So, as per the nomenclature we are using cis before naming this compound. Hence, the name of this compound is cis 1 chloro. This is following the alphabetical priority, and 2 methyl cyclopentane, cyclo because it is having cyclic structure, pentane it is having 5 carbon atoms, that is carbon 1, carbon 2, carbon 3, carbon 4 and carbon 5. Notice that chlorine and methyl group are both pointed in the same direction on the axis of the molecule, and therefore, it is said to be cis position. And when we compare this structure, we will found that these both OH groups are in different planes. So, as per the bonding, we have shown this OH group with dark bonding and this OH group with wedges bonding, or you may say that this dotted bonding. So, these both are in different planes, hence the name of this compound is trans cyclohexane 1,2 diol. So, if we discuss about the stability of these both compounds, we will found that cis form, due to having maximum repulsive force, is less stable in comparison to this transform, because these are far apart to each other. So, repulsive force is minimum, hence this structure is stable in condition. Now, we will discuss the location of alcohol substituents on cycloalkanes, which is more clear in this structure. That is, this carbon number 1 is having OH group, that is alcohol group, and this carbon number 2 is having 2 methyl groups. So, the IUPAC name of this compound is 2,2, or you may say that 2,2 dash dimethyl, di means 2 methyl cyclohexanol, or you may say that 2,2 dimethyl cyclohexane 1 ol, because this OH group is on carbon number 1. So, we are using ol for alcohol groups, and if we are using 1 dimethyl cyclohexane 2 ol, means if we are saying that this is the carbon number 1 and this one is the carbon number 2, then it will be a wrong description of this structure. So, alcohol substituents takes the highest priority for carbon atom numbering in IUPAC nomenclature. According to it, we have given the highest priority for this alcoholic group. The carbon atom with the alcohol substituent must be labeled as 1, which we have already labeled. Molecules containing an alcohol group as an ending ol, because alcohol functional group ended by ol as per the IUPAC nomenclature, indicating the presence of alcohol group. If there are 2 alcohol groups, the molecule will have di prefix before ol, that is diol. If there are 3 alcohol groups, the molecule will have a tri prefix before ol, then the name will be triol, and so on. In this structure, we are seeing that this carbon number 1 is having alcoholic group, carbon number 2 is having methyl group, and this carbon number 3 is having bromo group. So, according to alphabetical order, we will start from this bromo. The IUPAC nomenclature. So, according to IUPAC nomenclature, the name of this compound is 3 bromo 2 methyl cyclopentane ol. Rather, the name 1 bromo 2 methyl cyclopentane 2 ol will be wrong description of this structure. Now, we will discuss bicyclic alkanes, means the cyclic alkanes which contains 2 fused cycle. So, according to this, fused ring systems that share more than 2 atoms are called bicyclic molecules. The steps should be followed to name bicyclic alkanes are as follows. count the total number of carbons in the entire molecule. Example, 10 carbons in the system would be decane, 1 carbon, 2 carbon as per the nomenclature, meth, eth, prop, but, pent, hex, etc. Count the number of carbons between the bridge heads, then place in brackets in descending order as 2, 2, 1. Place the word bicyclo at the beginning of the name as per requirement. So, we may say that bicyclo is using as prefix. So, in this structure, count the total number of carbons. In this case, there are 7 carbons, means carbon 1, 2, 3, 4, 5, 6, 7. In this case, there are 7 carbons. So, the parent name is heptane. Now, in second step, count the total numbers of carbons between bridge heads, that is, this is the bridge head carbon. So, in center this is carbon 1. In this case, there are 2 2, that is 2 2 and 1 carbon between the bridge head placed in descending order between brackets. So, it is 2 2 1 as per the IUPAC nomenclature. Same in this structure, we are using bicyclo because these are showing 2 cycles, 4, 3, 1 decane. Decane means it is having 10 carbon atoms, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hence, it is decane. Ane means saturated hydrocarbon. And in this structure, we are saying it bicyclo means 2 cycles, 2 2 2 octane, that is this is containing 2 carbon atoms, this is also 2 carbon atoms and joined by this carbon number 2, carbon number 2. So, according to IUPAC nomenclature, the name of this compound is bicyclo 2 2 octane. Octane means it is having 8 carbon atoms, that is carbon 1, 2, 3, 4, 5, 6, 7, 8. For 8 we use oct and ane for the saturated hydrocarbon. In these both structures, we use the word bicyclo in front of the name. Say for example, bicyclo 4, 3, 1 decane and this one is bicyclo 2, 2, 2 octane. So, we may say that for 2 rings we must have to use bicyclo as per the IUPAC nomenclature. Now, we will discuss the methods of formation of cycloalkanes. Here we are having following methods are commonly used for the preparation of alkanes. So, first we will prepare or you may say that we will manufacture the cycloalkane from dihalide compounds. As in this reaction we are having 1,3 dihalopropane, that is 1, 2, 3 carbon number 1, carbon number 3 having 2 halogen atoms. So, the name of this compound is 1,3 dihalopropane. When react with this sodium in presence of ether, we have finally cyclopropane as the product of this reaction. Dihalides having halogen atoms on 2 ends of carbon chain react with sodium or zinc dust gives rise to the formation of cycloalkanes. This reaction is extension of Wood's reaction. This reaction, that is Wood's reaction, we have already discussed and is called Freund reaction. This reaction is helpful for the preparation of 3 to 6 membered carbon atoms cycloalkanes, that is cyclopropane, cyclobutane, cyclopentane and cyclohexane. Another reaction is Clemmensen reduction. In this reaction, the reduction of cyclic ketones takes place with the help of zinc, mercury in presence of HCl, which gives cycloalkanes. So, distillation of calcium or barium salt of carboxylic acid to give cyclic ketones which undergo Clemmensen reduction to give cycloalkanes. Here we are seeing that this reaction is going on in forward direction by using this dicarboxylic acid when reacting with this zinc and mercury in presence of HCl, we are getting here cycloalkane. Now, from alkenes we can also prepare cycloalkanes. Alkenes, these are the unsaturated hydrocarbons, means the hydrocarbons which are having double bonds among them. So, alkenes on treating with CH2I2, that is known as methylene iodide in presence of zinc copper couple, or by diazomethane, that is CH2N2 in presence of UV light, gives derivatives of cycloalkanes. This reaction is also known as Simmons-Smith reaction. So, as per the reaction, we are seeing that this propene, prop-ene, ene means double bond, prop means 3 carbon atoms, means 1, 2, 3. Propene when react with this methyl iodide in presence of zinc copper couple, we get methyl cyclopropane, this methyl and this one is the propane. And in another reaction we are seeing that this 2 butene means this double bond is located over this carbon number 2, that is carbon number 1, carbon number 2. So, known as 2 butene react with methylene iodide in presence of zinc and copper couple, we get 1, 2 dimethyl cyclopropane, means these 2 methyl are located over these carbon atom, that is carbon number 1 and carbon number 2. Hence, it is known as 1,2 dimethyl cyclopropane. So, by using these unsaturated hydrocarbons, we are getting saturated hydrocarbons. So, we may say that this is the example of addition reaction. Another reaction is Dickmann cyclization. In this reaction, esters of dicarboxylic acids when react with sodium undergo intramolecular acetoacetic esters condensation and a beta ketoester is formed. These beta ketoesters on hydrolysis and subsequent heating gives cyclic ketones, which are reduced by zinc mercury in presence of HCl to give cycloalkanes. So, you may say that in this by open chain we can get the cyclic structure of alkanes. In this reaction we are seeing that it is the open chain compound, that is diethyl adipate, which is finally by various steps converted into cyclopentane, and this is the final step in which this ketonic product is converting into cyclopentane in presence of zinc, mercury and HCl. From aromatic hydrocarbons we can also prepare cycloalkanes. According to it, 6 membered cyclo compounds can be easily obtained by the catalytic reduction of benzene and its derivatives. This reaction shows that this benzene when react with this hydrogen molecule in presence of nickel and at higher temperature, we get cyclohexane. It is 6 carbon membered cycloalkane, and when this phenol react with hydrogen molecule in presence of nickel and 200 degree centigrade along with pressure, we get this cyclohexanol. All we are using for this alcoholic group, and in presence of zinc dust it is finally converted into cyclohexane, that is further a 6 membered compound. Cycloalkanes can also prepare by using Diels-Alder reaction. In this we may say that this is a cycloaddition reaction. It involves 1,4 addition of an alkene to a conjugated diene to form an adduct. The reaction is initiated by heat or Lewis acids. So, we have used the term conjugated diene and alkene. In this reaction we are seeing that this reactant 1, 2, 3, 4, that is 1,4 butadiene when reacting with this unsaturated reactant, that is ethylene, in presence of higher temperature, we get cyclohexene, which is ultimately converted into cyclohexane. So, we may say that is unsaturated compound, and finally, we get saturated compound in the form of cycloalkane. Viewers, in this episode we have discussed introduction of cycloalkanes, nomenclature of cycloalkanes as per IUPAC system, methods of formation, that is by using alkenes, by using aromatic hydrocarbons, and by using Diels-Alder reaction, in which we have used 1,4 addition reaction. And in next lecture we will discuss about the physical properties of cycloalkanes, chemical properties of cycloalkanes, and ring strengths in cycloalkanes.